Hello, good morning. Welcome. Today it's a pleasure for us to have here Carlos Sierra, Professor Carlos Sierra, the director of the Institute de Investigación en Inteligencia Artificial. So he's our neighbor.
Yes.
And we thought that it would be quite interesting to invite him to tell us what our neighbors are working on artificial intelligence. Carlos Sierra got his degree and his PhD in informatics at the Polytechnical University of Catalonia, because at that time there was no artificial intelligence.
As a degree, no.
As a degree. And since then on, he has developed his scientific career at CSIC, in fact. First in Blanes, in the Institute Centre d'Estudis Avançats de Blanes, and later on here. And he has also made some stays at the University of London and at the University of Technology of Sydney. And he's also been the coordinator or the president of the European Association on Artificial Intelligence. And he's also the coordinator of the CSIC Hub on Artificial Intelligence.
Correct.
And he told me not to extend too much on that. So I just welcome, and the floor is yours.
Thank you very much, Lourdes. It's a pleasure to be here with you. And sometimes we, as neighbors, we don't talk enough. And I think that could be an opportunity, of explaining you a bit what are we doing, but also what is AI, what is the crossroads where AI is at present, because it's an interesting situation. So first, I will try and explain you. Maybe everybody knows what AI is about, but I would like to give my view on it, because that will make you understand where the Institute is placed in this area. I think I will put myself here, maybe. The camera follows me, I guess, or not. So I have to be there. I see that the camera doesn't follow me. Okay, fine. Now, no, I'm okay. Okay, so what is AI? Now, there are many definitions of AI, and we have been using definitions that are not this definition. But the Parliament, the European Parliament, has been struggling trying to define what the hell is AI, because it's a difficult thing to define. At the beginning, in the first drafts of the law that is being approved, we had a list of techniques, basically. People were saying reinforcement learning, data analytics, Bayesian estimation. There were a number of techniques, but there were a lot of critiques to that. Actually, there were critiques about the fact that AI should be regulated. Many people said what should be regulated are vertical areas like transport, mobility, or health, but not a particular technology. So there are arguments in pro and against. I don't know. You don't regulate in a law the use of magnetic resonance. Okay, so why AI should be regulated? The reasons for that is the transversal element that AI has, that it affects all sectors. That was the argument. If you read here, this is bullet number 12 in the law. Basically, what you see in boldface at the bottom is three basic categories or three basic properties of software. Any software that is capable of learning, reasoning, or modeling is considered an AI system, okay? And by saying that, it means that the law applies to whatever system you develop with those techniques, okay? So that would be, I would say, the official and legal definition of the field for the future. The history of it is very long, and we could spend a couple of weeks talking about the history, but I would go very fast. I want to start with Ramon Llull, that I think we are from the country of Ramon Llull. I think it's good to mention him, because he developed these kind of devices in his books in the 13th century. They were kind of wheels that would rotate, and there would be letters facing one to the next. And those letters would lead you into tables that would be used to build up proofs of claims, logical claims, okay? So he was in the I would say, in the mood of willing to prove that others were wrong by building formal proofs of why he was right, okay? That was a very interesting development. We don't have time to talk about that, but that would be, according to the European Parliament, an automated reasoning system. That would be AI, because the plan of that was to automate the reasoning. Leibniz was in love with Ramon Llull in his PhD, and he used many references to what Ramon Llull did. He changed the letters to numbers, and he said, well, we would compute our disputes, and we would solve them by just computing. George Boole, that formalized propositional logic, propositional calculus in the 19th century. And this guy, William Beth, I don't know why, there is this bar that is, okay. William Beth, he invented in the mid-19th century, 20th century, sorry, I still thought I'm in the 20th century, the tableau analytics. Maybe you don't know about it, but it's a formal proof procedure in logics. And it is exactly the same as Ramon Llull proposed 700 years before. So it's exactly the same thing. Opening the proofs and trying to disprove to find contradictions in all the branches that you open. Exactly the same as Ramon Llull did. So we can go that late in history, and I need to start accelerating because I talk too much. But normally, in the 20th century, people talk about Alan Turing as the one that, in a paper in 1950, put himself the question whether machines could think. Because, I mean, it was at the end of World War II, they had cracked the Enigma code of the Germans. So there was this excitement about what computers could do, and the question was, could computers think? Now, he was an engineer, he was a mathematician, but with an engineer's soul, I would say. And he was always saying, well, what does think mean? I mean, this is a very badly defined concept. So he said, well, I will define a proof or a game, and then I will define that someone that wins that particular game will be labeled as a thinking entity. Okay, so it was an engineering approach. And the game was this one that you have, everybody here in the room probably has heard about. Later was called the Turing test. It was not called the Turing test by himself, of course, but it was labeled as that. And basically what you have is a guy in front of a keyboard that is having a chat, like you have now with ChatGPT, right? In a chat, and you talk to some entity that is behind the wall, and you don't know whether there is a human or a computer answering your questions, okay? Now, if the person at the keyboard says, oh, there is a human on the other side, and what is actually there is a computer, then Turing said, well, we would say that that computer won the game, and we would qualify that as a thinking entity. How many in this room think that there are already computers that have passed a Turing test? He was thinking around 5 minutes. So in a 5-minute conversation, do you think there is any system that has passed that test? I don't see any hands raising because you are shy. You think it has? It depends on the person. Very good. No, in principle, he's a lay person, not a researcher at the ICMAB. Okay, so some people may start thinking that some computers have passed that test. Okay, many things passed in the well. There are some objections, of course, to this. Passing the test doesn't mean the machine thinks. But Turing would say, no, he never said that the machine thinks. He said, I would label it as thinking when passing the test, but because I don't have a definition of what thinking means. Okay. Other arguments against it is a simulated something is not that thing. So it's different, simulating thinking than thinking. And it doesn't explain how the machine works. The fact that the machine passes the test doesn't explain that. But this argument is a bit waffy because, I mean, we don't know even how our brains work. So not knowing the internals is not possibly the best reason. The second, maybe everybody knew about the Turing test. How many know about the Chinese room? 2 people. Very good. The Chinese room was proposed by this philosopher, John Searle, in the 60s, actually. But He reformulated it in the 80s in a paper called Minds, Brains, and Programs. This guy was very much worried about what thinking was. And he imagined the following situation. You have a room, that's why it's called the Chinese room, okay? There is a room with a person inside with big books. And there are two trays, one where you put a question in Chinese, and there is an output tray where the person that put the question receives the answer, okay? Inside the room, there is a person that doesn't know Chinese, but that has these wonderful infinite books that he can very fast go into them, look for the question, and copy the answer that you have next to it. Copies in a paper, he copies very well in Chinese, and puts it on the output tray. Now the question is, of course, I mean, and you can answer easily, does the person inside know Chinese? He doesn't. Does the system know Chinese? Which means the person, the books, and the room. And here is where the philosophical points appear, because for him this is the fundamental question on thinking whether computers can ever think or can ever reason or can ever do things like that. I mean, the argument would be, even if the guy in the room doesn't understand a word of Chinese, the whole system does. And then manipulating symbols is equivalent to understanding. This is at the core of the symbolic AI approach. We'll talk a bit later about that. Some people will say, learning the set of rules is the same as to understand Chinese. So what we do in our life is learning the book. So there is never anything like comprehension. So there is always the learning of these input-output patterns along our experience in life. So this is exactly what the human beings do. Sorry. Of course, the size and complexity is so huge that we make us unaware of that. But we are, in the end, symbol manipulators. Okay, so this, as you can imagine, the number of discussions about the Chinese room was massive. But it opened the basic, I would say, division in artificial intelligence till nowadays. And one is symbolic AI, which basically takes for granted that what we are and what machines are is symbol manipulators, nothing else. And the first program in this line, probably the first AI program ever, was in 1956 by Herbert Simon and Alan Newell. Herbert Simon was a Nobel Prize winner in economics. And that guy there, the John Clifford show, they were all mathematicians. He was a mathematician that was the programmer of the solution. Basically, what this thing does is to try and prove a theorem. How do we prove theorems? We have a number of axioms, and we have a number of rules, deduction rules, that allow us to combine axioms and obtain new true formulas. It's truth-preserving systems, right? So, for instance, if you have down there A implies not A, altogether implies not A. Probably you all remember your studies when you did your degree or at the high school in where you had to prove these things. Okay, you can say, well, A or A implies A. This is an axiom, okay, that we are given. There is a rule that says if you substitute something by its negation, the truth is being preserved. So if not A or not A implies not A is derived from the previous one. We replace the disjunction by the implication. If you remember, P implies Q is not P or Q. Then you have A implies not A, implies not A. And this is what you wanted to prove. Okay? So by taking the axioms and some rules and manipulating symbols in the same way as the Chinese guy, well, the non-Chinese guy in the room, you can do that. That was the computer you have there, the Joniac, this massive computer, took 10 seconds to solve this proof, to find this proof. It was programmed in IPL, in machine code. At that time, everything was very artisan-made. Okay? So this is a clear example of symbolic AI. Now, if you ask DeepSeek, you would have a proof, I mean, a beta written and definitely much faster. I mean, this takes milliseconds to get that. But of course, we can talk a lot, if you want, about these kind of models, because they are basically looking for patterns. I mean, this is not because it reasons, it doesn't reason, but it finds patterns of proofs that it can reuse in answering questions, okay? Which is a different, completely different thing. What is subsymbolic AI? An example of that are the neural networks. And they are old. Well, neurons are, of course, in our brains. And there was a very interesting guy, Ramon y Cajal, Nobel Prize in 1906. I have to guess my last line. Who did the nice drawings that you see there. And he is the one that developed the theory that neurons are not a mesh, but they are separated by a space. So there is an electrical communication, but then there is a chemical communication between the neurons, okay? He did beautiful drawings of that. Now, this model inspired people already in the 40s to have mathematical models of what a neuron does, because he mentioned the fact that the axons and the dendrites connect, okay? And that the information passed from the axons to the dendrites, and that the soma, which is the body of the cell, basically integrates the input it receives, accumulates somehow them, and then fires the axon. That's the basic model of a neuron. So McCulloch and Pitts, they developed the perceptron in the 40s. That was the first neural network that you could that we had in a computer. Okay. This has evolved, and I think well, that was Marvin Minsky and Claude Shannon. I mean, Shannon is the information theory guy, and Marvin Minsky is one of the fathers of AI. He passed away a few years back, and they took the leftovers of a bombarder from the Second World War to build a machine that was capable of finding the exit in a maze, okay? Like a mouse when it moves to get out of a maze. So they solved the maze problem. It was called the Theseus. Of course, you remember the Greek, okay, Theseus, the name. And basically, back then there was, but they didn't use it. But later, after, okay, so that was an implementation in the 50s. Then in the 90s, where is this? Okay, sorry. If you see there, I mean, how these things work. So you put an input into these neural networks, and then they propagate by following an equation similar to this one, to the one you see there at the top right. You go to the end, and then it determines a certain intensity in the output cells. These output cells correspond, for instance, to classes when you want to classify inputs. Images, for instance, you have images of cats, and then you have a cell that is cat and another cell that is dog. So if it activates the cell cat when it was a dog, you will give the right answer, and that will compute an error of what has been predicted and what is the reality. Now, the computer, the algorithms, what they do is they modify the weights back so that it improves that error. It decreases the error, okay? Now, in 1990, there was a discovery of an algorithm, a proposal of an algorithm based on, called backpropagation. Backpropagation is not exponential in the way that it improves the changes in the weights, but it's linear. And that made a gigantic leap in the use of neural networks. That was in the 90s. Although the algorithm had been discovered in the 60s by a guy that was not, probably he published in Hungarian or some strange language and was not paid attention. So you see, so you go ahead, you compute the error, you backpropagate the modifications, and then you do it again. And that's why these systems do it over and over again, because they approximate. They do not compute analytically, it's too complex. So they need to do it in subsequent approximations. What deep learning is nothing else than a massive, a huge neural network with hundreds of layers and billions of parameters. Every connection, every link there is a parameter. So things like ChatGPT may have the newest versions like 600 billion parameters, which is something that goes beyond what we can imagine, right? And this has been improved because of the game, people playing games. Because I mean, the hardware developed these kind of GPUs to make games very fast, and they compute matrix operations in a very fast way. And that's why deep learning now is a fact, because of video games. Anyway, what people do with that, I mean, you can see here, I mean, this is a very simple and silly example where you have handwritten examples of writing the letter E. And if you discretize that and you put ones and zeros to the way you write it, you could classify that into the code 11000101, which is the code of E. These are the output. You can have like 2, 4, 6, 7 cells at the output, where there should be 1 or 0. And then you put this is an E, you put the correct E, and you compute again the errors, you go back 4. And in a few, very fast, you can learn how to detect handwritten text, okay? Okay, so this has been a historical conflict between symbolic and sub-symbolic approaches. So at the beginning, there were more or less two different approaches. They were not fighting, but then they were fighting. Some people say you will never do correct things, you will never do practical things, and they were fighting. In the 90s, the community separated, and they continue quite separated. Now there are interest in rejoining them in conferences. But for you to know that there is a classical dispute between both. Now, this dispute would at some point settle. That's my thinking. And many people, for instance, you have LeCun, which is one of the fathers of deep learning, has already mentioned that there needs to be an approach that combines, on the one hand, the sub-symbolic approach that is very good for language, with cognitive components like planning, like reasoning, like situation modeling, that should be combined into architectures in the future, okay? These drink from some work that was done in the 70s, but this is probably what we're going to see in the future. And if you see some of the calls at the European Union level, they go in this direction of putting together symbolic approaches, the classical one, reasoning, with sub-symbolic approaches, which is language generation together, okay? What is IIIA? I mean, we are, I would say, for tradition, we are 80% symbolic, 20% sub-symbolic. And this is changing. And this is changing because this is what the society demands. I mean, nobody asked us to do a project on beautiful, successful reasoning, but they are very interested in the use of deep learning in many applications. So we are changing a bit our focus from a more symbolic approach to a combination of both. Okay, I will give you very quickly a few ideas of what is IIIA and some things we are doing there. So we started in 1985 in Blanes, in Centre d'Estudis Avançats de Blanes, and we moved here in 1994. You were already here in 1994. Okay. So we have, these are very boring things, but I mean, we are basically research staff with some IT support, okay? And the research staff is divided into, I would say, half and half, probably similar to you, between research more senior people and students, PhD students. So we have here a bit, in terms of gender, our situation is pathetic in terms of gender. I don't know in your case, I see here, not bad, you're not doing bad here. No, okay, we're doing very bad. You see here is the women are the line at the bottom. I mean, when I became director of the institute, I put all my effort in trying to hire more women, but it's extremely difficult. I mean, maybe in your area it's a bit different, but in our area is terribly difficult. Well, this is not very interesting. Public servants and hired people. I think we have around 40% of our personnel is on contracts, which puts, of course, pressure on the need to get projects all the time. Very much focused on PhD students, not so much on master students, and this is possibly because we are not Instituto Mixto, so we are not in combination with universities, and that makes having master students a more tricky thing. That's not interesting. The evolution of the institute is that we survived the retirement plague. So I don't know here, but I mean, for us, retirement has been an issue and is being an issue in the next 3-4 years. So we are more or less with the new incorporations, we are kind of maintaining things on a stable way. But never mind, we are a small institute. All over, if you go to the web and you count all heads, we are around 110 people, so which means we are a small institute. We are qualified at Institute B, but you are probably an A, right? You're big. Okay. The budget is around 3 million a year. This is how we compute it. Think that we are cheap in the sense that we only need computers, paper, pens, blackboard, chalk, and very little more. I mean, and if we use some computing resources, we have some in-house, but we use supercomputing centers outside. So we are cheap. Now we are creating a new lab on robotics, and that will be expensive because robots are really expensive, and it will be operational in the next 5 to 6 months. Okay, this is a bit of numbers. We have graduated around 120 PhDs. We have generated a number of spin-offs. We are internationally, we have been quite recognized, and for instance, IIIA, which is the European association that I was the president of for 4 years, has recognized 7 of us as fellows. And this is quite a prestigious thing. Probably is the institute in Europe with the largest number of fellows nowadays. So I think internationally, the institute is quite well known. Okay, what do we do? Very quickly, because I will put you, how many hours is my talk? No, seriously, I think I have done 20% of the material. Okay, so we have 3 departments. One is on learning systems, which is the most popular nowadays, okay? It has been diminished in the sense that these people are very much on demand by the market. And the problem in organizations like the CSIC that has these tremendous salaries, you know, so attractive salaries, is that people tend to go to the market. And so it's difficult to maintain. But anyway, we work on probabilistic graphical models. This is related to causal inference. Causal inference is a key in knowledge discovery. I mean, many people in science are content with just correlations, but correlations are a disaster. I mean, for instance, there is an increase of consumption of ice cream, and there is an increase on drowned people in the beach, okay? There is a clear correlation between the consumption of ice cream and the number of people drowning in the beach. So is eating ice cream causing people drowning? I don't think so. The thing is, both happen in summer, because in summer is when you eat ice cream and when you go to the beach and then you drown, I mean, there. Okay, so finding the causal reasons of the effect is the basics of science. And many people are, in particular, neural networks, massive correlation searching devices. I mean, so anyway, there are people working on causal inference. There are people working on deep learning, of course. Nowadays, case-based reasoning, which is something the humans do constantly, is when we solved a problem in the past, the current problem is similar, we take the solution that worked and try to adapt to the new situation. So this is another mechanism that for which we have developed algorithms in history. Computational creativity, and applications in a number of areas. I will put an example later on healthcare, but you see here the areas where we have applied that. Multi-agent systems. I mean, this is now becoming very fashionable under the horrible name of agentic systems. This is my area of work. I mean, multi-agent systems basically is about the interaction of different artificial intelligences to solve complex problems. You can imagine, for instance, a typical example, autonomous driving. You will need all the cars to coordinate in order to have safe driving on the roads, okay? So that is a multi-agent system in which the individuals, the elements, the agents are autonomous, independent, but never mind, they need to talk to one another, okay? And here you have things like, well, I will talk a bit about ethics and AI I will not have time, but anyway. Organization and coordination mechanisms, for instance, negotiation seems like a normal mechanism for this. Trust and reputation, do you fulfill what you promise? Can I trust you for future interactions? Semantics, what does it mean, what you say? Now they are fixing that in agentic systems by using English. If that is not, maybe you have heard about the IIIA system that the Chinese are putting on the space. I mean, they have now 28 satellites. They're connected by laser, and each one of them has an LLM solving stuff, okay? And communicating through the laser system. They plan to have 2,800 satellites in a constellation up there to do the computation, AI computations in space. I don't know how they refrigerate the thing, but I mean, someone will. Anyway, semantic agent-based simulation, there will be an example of that as well. And the areas where we apply it, okay? Logic and reasoning, this is the most traditional one. Remember, Ramon Llull, 13th century, okay? So this is a group that has been working on, these guys write theorems and prove them, okay? Things like mathematical fuzzy logic, so alternatives to classical logic, logics that are closer to the way humans reason, right? Uncertainty, how do you deal with uncertainty? SAT and MAC-SAT, which is satisfiability algorithms that try to find exact and correct solutions to problems. For instance, for optimization. Meta-heuristics, this is more approximate solutions like evolutionary computing. So there are people working on that as well. Okay, in applied areas, health, education have been the most important ones. Mobility is very important. And then coordination, and the theory of coordination applied in certain social networks, I would say, and industry. These are the areas where we have worked more. IIIA, how does it fit? I would say is 80% fundamental, 20% industrial, okay? So the industrial applications are relevant and important, but they are not as important as the fundamental research. This is how I define the institute, let's say. You mentioned the AI Hub. We are also coordinating the AI Hub, which is working pretty well. We had just 2 weeks ago, we had the summer school in Zaragoza, fantastic city with temperatures above 40 every day. Bloody hell. So there are more than 400 researchers all over the CSIC that are interested mostly in applying AI to their research, but also, of course, doing research on AI. And you see here 45 centers, 92 research groups. And we have organized a number of things like we have a co-fund with a number of postdocs. If you are interested, I mean, and you are not yet a member, but you want to use AI, I suggest you enroll there. Learning systems, very quickly, because I guess, at what time do you want me to finish? At 1 o'clock, fantastic, okay. I thought you wanted less, okay. So this is a European project. It connects machine learning and healthcare. And the idea is using computer vision to analyze medical images. That was the technical or the technological platform. And the idea was to apply is to assisted reproduction technologies. What was the idea? The success rate in assisted reproduction is very low, around 25% only. There's a number of limitations in the current methods, and basically the idea of the project is to develop machine learning algorithms to predict the success rates, whether there will be success, the implanting of the oocyte or the egg, sorry. I'm not working on this, I'm trying to find the English words. Identify the gametes and embryos with the highest chances, and improve the diagnostic and prognostic capabilities of the methods they have. So what the hypothesis they had, one of the hypotheses, they wanted to validate whether oocyte expansion in the female is relevant for the success of the embryo. At some point, the oocytes that are these, women have millions of them, well, millions, hundreds of thousands of them, but at some point they start growing, okay, some of them, and they will become an egg. Now, the rhythm of this expansion could indicate that the embryo would be a successful embryo. So they developed an algorithm that was based on human annotators and combined what human annotators mentioned. Those are the levels or the detection of these eggs through imaging. And the proposal that the system had this superhuman segmentation capability. So it was much better than any of the individual annotators, okay? So the algorithm using the data of the annotators managed to be better than them annotating. They produce a number of, results. They had, the one I was mentioning is the second one, the AI expansion. It reached human level performance for cumulus expansion estimation that indicates oocyte maturity. So they verified these hypotheses and they developed a system that is capable of doing that. They also did other things that for women, they need to receive some doses of hormones, in particular this follicle stimulating hormone. And it's very important that the amount of hormone is the right one, okay? Now, what they managed is that they improved 31% with respect to the clinical practice into the successful dose for women to have a successful embryo, okay? Okay, this is an application of machine learning into healthcare. This is, I just put these slides 2 minutes before coming here. This is Bullseye. You know, we have this, our friend Ignacio, the General Secretary of the CSIC. He is very much interested in using AI everywhere. So he charged us with something which is improving the bolsa. You know, the bolsa of the CSIC, the infamous bolsa. Now, we are developing a tool that will try and improve some of the part of the process of the bolsa. And that is the evaluation of new candidates. That, as you know, sometimes it takes 2 weeks, 3 weeks, 4 weeks, you never know how long. It only appears on Wednesdays for some reason. I mean, if it is a Thursday, you will not have anything, but on Wednesdays you may have. Now, so the idea is that the manager of that process would define criteria that needs, we'll put you an example straight away, of what the evaluation should be, okay? Now, the artificial intelligence tool we are developing will generate the verification steps. It will apply it to the documents provided by the person, will give the decisions for the manager to check whether he agrees or not. It will give explanatory capabilities for the manager, so it will say, oh, why is it? And it will show where and in which document the information can be found so that he quickly can click, 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 pass candidates, okay? So it's a system like this. There are 2 functionalities. There is a manager of criteria that will determine what are the criteria to evaluate, and this is a generic tool. We are applying it to the Bolsa, but they will apply to other parts of the administration. So there was a first AI system that will generate a number of instructions to verify, And there will be another functionality on the verifier that, taking into account the data and the instructions to verify, will use another AI to actually verify them. So you have there, for instance, let's put an example. El aspirante ha trabajado al menos 3 años en un puesto relacionado con su área de especialización. This is something that is in the requirements, okay? Now, the first AI says, to verify that, you have to do analizar la vida laboral del aspirante, identificar puestos de trabajo y su duración, relacionar puestos con áreas de especialización y calcular la experiencia acumulada. So these are the steps that the system determines should be done. And then the second AI will determine, that will be the criteria 3, will give it is satisfied with a click, so the guy can just believe it or not. If it doesn't believe it, can ask for an explanation. If it asks for an explanation, it will show the document where this information can be collected, okay? So we hope this will improve that particular part of the problem we have so far is that we are still not getting actual data. We have been working for months on this, but I mean, no data is still coming. Anyway. Okay, so this is another application for you to see how we apply AI to practical things. Logic and reasoning. These guys have been doing things like, for instance, logistics. In logistics, you need to do distributed optimization because you have moving boats that need to meet a certain harbors and they need to move containers from one to another. Because if I want to send a container from here to Beijing, well, not Beijing, no, Shanghai, and there is no direct ship, then I can go to, I don't know, Cochin in India and then change there for something. So this requires distributed optimization, which is a number of different boats that need to decide how to meet for how long and so on. Planning and scheduling in hubs, transport network planning that applies also to trucks that move around in roads. Or automated negotiation, I mentioned that before. I mean, when you need to move a certain good from point A to point B, you have a number of providers that could do that moving. So you would like to have an automatic system that negotiates with the different providers and determines which is the best one and closes the deal. So this was another European project in which we developed algorithms in these areas. Another thing now is, this was a proto project, but it's very interesting. You know, near Cordoba, there is a place called Medinat al-Zara. I don't know if you have been there. Have you ever been there? It was a palace but that was abandoned and is a ruin. And it's a ruin at the level that all the walls were covered by clay, very beautiful clay designs. And they broke. And they have 400,000 what they call atauriques, which are pieces of this clay. Now, can you imagine the jigsaw? I mean, it's absolutely crazy. You know, if you want to recover how they were positioned, I mean, you need a legion of slaves, I guess, or some AI. In this case, combinatorial optimization techniques that from a 3D scan of the images would try and put them together into how they were done using evolutionary techniques. So we have a project. This is an example of collaboration. I mean, we like to collaborate with other institutes, and this is a message. I mean, this is a collaboration with the Institute of History in Madrid, okay? We are collaborating with our famous Ignacio, the Secretary General as well. I mean, so many of our projects are in collaboration with other institutes. Multi-agent systems. I will talk about one that is also a bit visual, which is called RIMAS. It's a simulation framework to help training firefighters in emergency situations. I mean, you cannot set fire to a building for the firefighters to learn how to extinguish it. So the idea would be to simulate an emergency and use a number of technologies for them to be trained. That's the idea. Mixing artificial agents and humans. You see images. I mean, you cannot provoke these things for them to be trained, of course. So this immersive simulation, immersive in the sense that the firefighters will have all sorts of virtual reality elements in order to be trained, but being trained in a safe environment. So you can train in a dangerous situation, in a safe environment. It's not actually happening, but they perceive it as it is happening. The engagement is much bigger than listening to a guy like me talking and explaining what should you do in an emergency. You should do this and that. No, they are placed in a situation that emotionally engages them. Also, for the trainers, they can check on the trainees whether they are progressing or not. They can monitor their progress. And of course, the cost is much cheaper than provoke an emergency, right? So it's a reasonably cost. Thank you. So the one on the left is a bit of science fiction. They don't have it, but the firefighters have this sim table where they see things, for instance, fires spreading over a territory. They also have a cave. This is done in collaboration with the firefighters here across the road. Okay, they don't have a cave, but they have a frontal thing similar to a cave. A cave is more expensive, and they have, this is an actual firefighter. They have virtual reality, so they can be on a situation seeing images, and so this is another successful project. Now we are building this robotics lab on social robotics, and we are also combining it with virtual reality and extended reality. Okay. One of the particularities of this approach is that they have a multi-layer simulation, which is quite unusual. So you can simulate what the firefighters are doing and how they communicate and so on, but then you have the sergeants and the captains, and you have different levels, a whole hierarchy, where people are also taking decisions that affect up and down. So the simulation is known as a multi-layer system. And they can be, in the training at school, they can be different rooms playing different roles in this simulation. I will skip this. This is about values, but anyway, I will skip this. Sorry, I prepared too many slides. But then we can choose. I want to show you a bit, because I have 12 minutes, 10 minutes, 8 minutes. Some shadows on the use of AI, because not everything is happiness. There are some misleading claims. That's the first thing. We are in the time of generative AI. ChatGPT and Midjourney, all these systems, they generate content from content they have received as input. They have been trained, they create a model, and then they generate things. Many people believe, some crazy Americans, believe that this is a step towards general AI. General AI was the dream of the 60s. It's a system that would be able to solve problems of any sort, okay? Like humans, that we can fix a chair or plan a trip or diagnose someone. I mean, we can do many things. So general AI would be something that could do all these things at the same time. Generative AI is by far not near that thing. There are many risks if we do not develop responsible AI. I will mention a few of those. We have the example of the lethal autonomous weapons, that there has been a movement to try and forbid them, ban them, but they are being used in Ukraine, in the war in Ukraine, every day as we speak, okay? And the problem of biased data, that is also a big problem. Well, I would say these systems, they have a lack of understanding. I mean, we have to go back to the Chinese room thinking. I mean, these systems are the guy inside the room, okay? Is the guy inside the room. They don't understand the input-output connections. These machines, when they are even trained, the tokens, they are trained on tokens. You put a number, you take 50,000 words in English, you give a number to each one of them, and you use those numbers. I mean, they have no relation, no experience. They don't know what chair is. How do you feel when you sit on a chair? No, it's a number, a token, and they can generate chair in many sentences, but they don't know what a chair is. We have to be clear with that. There is no true reasoning. It's not like the logic theorist, in where you have the axioms, the rules, and you could explain clearly why a certain theorem was proved in a way that a mathematician would understand. These systems are not reasoning. These systems are, in the best case, using patterns of reasoning and using them to generate text, but they do not reason, okay? They depend on the training data. I mean, if you change the training data, the results are different. This is like Groucho Marx. I have my principles. If you don't like them, well, I have others, okay? So if you change the training data, then the thing changes. I mean, there are no independent intentions, goals, motivations, or decision-making capabilities. There is no agency in these systems. And there are biases and errors. I mean, depending on how do you train the systems, it will become a fascist, and there have been examples in the past, or it can be a misogynist. I mean, anything you can imagine. And of course, they don't have a body, so there is no real interaction with the world. And it is, many people would say, many neuroscientists would say that our brain is part of a body. I mean, if you don't have a body, you cannot have the same functionalities that we as humans have. Well, the risk of non-responsible is bias discrimination, and this is especially important when you are thinking about hiring people. Here in the Bullseye application, we are at the edge of things. Law enforcement, social services, very, very, very dangerous here. The accountability, I mean, here, I don't know why there is so much issue with accountability, because for me, the accountability is very clear. Who developed the software? You developed the software? Then you're responsible. I mean, that's it, you're accountable. I mean, it's your software that is being used for something, no? If the car does something that is wrong, I mean, you go to the car manufacturer and you say, look, guys, I mean, this is not working. Anyway, but nowadays, there is a claim by some of these big companies that they are not responsible, that it is just the users. They just give the software and then the users will determine what to do. Anyway, I would just finish. The lethal autonomous weapons, there is a lot, I've got discussions with some Israeli friends because they defend these, of course. They say, no, we send killing robots through the trenches. And so there are a number of arguments in favor that you can see here, but of course there are a number of arguments against, in particular, serious ethical concerns. I mean, how can you leave to a machine the decision of whether it has to kill someone or not? I mean, ethically, this is very debatable, at least. Anyway, bias data, well, you know about biases, right? I mean, you deal with data. I mean, you can have sampling biases. This is an example with the bird population. If you say, well, I don't have much money, I will just sample next to the roads, right? To see how many birds are in a population. This can be a disaster because maybe the birds are far from the roads because they hate the noise and they want to be in a more peaceful way. So your numbers can be completely wrong because you are sampling in the wrong way. The confirmation bias, I mean, there was this thing of the ether in the 19th century that it took a long time for Einstein's theories to be accepted because people thought there must be the vacuum cannot be, there must be some ether. And what they did is any potential support for the ether was accepted and anything against it was just dismissed, okay? So there was this confirmation bias by many scientists in physics, okay. And the other thing is the survival bias, that we only talk about those, for instance, in entrepreneurship, those that are very good, they survived, they became rich because they were very good. But we don't know about all the others that failed miserably in doing the same thing, right? Or for instance, you open a mathematical teaching course, advanced mathematics in a high school. And of course, some abandon it, but those that continue, they are extremely good. They improve mathematics a lot. But only those that continued the course, those that abandoned, you're not taking them into account. You cannot draw conclusions from that. This is the survival bias. There are millions of biases. Anyway. Well, I can pass you the slide. This is very funny. Because this is about the fabrication of things, the plagiarism in paper mills. I don't know if you have found, this is very, read in the color thing. These things have been published, I mean, believe it or not. I mean, people don't even take care of checking the text in journals. And these are reputable journals. I mean, it's not, I'm not making it up. I mean, this is, well, anyway. Material science, who knows genome? Okay. So this is a system that was developed by Google DeepMind. Google DeepMind, they're massive creators of stuff. I mean, based in London, they started in Oxford, based in London, but in many places. Google was very clever getting them and buying them. So what happened here is that, I don't know your area, but what I've heard is that basically you take a structure of a material, and then what you can do is you can change some atoms. And so you change some elements in the structure, and then you see whether that material is stable, can be produced, or... So this system has two deep learning models. The one generated more than 1 billion structures, making modifications in existing materials, okay? So it proposed potentially reasonable materials by modifying the formula of the material. And the second one would predict the stability of the material just looking at the chemical formula. Okay, not building it, but looking at it, say, well, it will be stable, it will not be stable. It will have this or that property. So they predicted the structures for 2.2 million new materials out of that billion that was generated. And 700 plus have been created in the lab. So I don't know, but in material science, it seems like getting your hands on top of these kind of systems could be a good idea in order to develop new materials. I mean, as you can imagine, it shortens the process. For instance, in proteomics, people to find the 3D dimension of a protein in the past would require almost 3 months in a lot of computing, and they had to go to the CERN. It was a complicated thing. Now you can have it in minutes and sometimes in seconds, the 3D structure of a protein. My guess is that in material science, I mean, probably you can make your work faster by using systems like this, genome. The other thing that I wanted to mention before I shut up is that the EU is building a strategy on AI in science, but not only our president in the CSIC, she is very focused on AI in science as well. So the EU is preparing a strategy. I've been consulted, I've seen the draft, and there are a number of things. So that means there will be billions of euros behind this in the next years. I mean, so basically what the paper says is that there should be better coordination at the EU national levels. We need to have a way of monitoring the impact of AI, because now there is a lot of hype, as usual. Oh, AI will solve everything. Well, we need to monitor to see whether that's true or not in all the fields where it is applied. Researchers need to be upskilled, so people need to be formed, educated in using AI techniques. There should be an ethical approach, and everybody has to be, I know, for some people this is philosophy, but we need to know that what we do is made under ethical or based on ethical principles. I mean, we can make a lot of serious mistakes otherwise. It has to be open access, again. I mean, this is the philosophy. Improve the interconnectivity, and connected to these are all these gigafactories that are being created in Europe, and so it's building infrastructure for the researchers in all fields to work together. Okay, so I finish here. Well, there is a rich history of work, and I would say interdisciplinary work of AI, with the ultimate goal of automating, emulating, you put the verb you want there, some of our cognitive capabilities. I mentioned the law of the European Parliament. I mean, is reasoning, learning, and modeling as the three basic human capabilities, cognitive capabilities. It is having a tremendous impact in the way science is performed. In many areas, it is so. And in many other areas, like in health or in education, it's also having a very big impact. So probably it's good to have a look into how it is being used in our own works. Well, and the final one is, of course, that we have to be, AI has to be responsible and preserve the scientific principles and the ethics that we apply in science. It cannot be otherwise. And just to finalize, I mean, we are neighbors, so we meet, your director and me and myself, we meet in meetings, but I mean, preparing maybe projects together. I mean, the good thing is that we have a single PIC number, so we don't need to be two partners in a project. We can be one partner, the CSIC. Actually, in Europe, we are the Agencia Estatal, whatever. We are a single partner, so you could build up teams in which there are researchers from here and researchers from our institute, and be a single partner. Because sometimes they say, we don't want two partners from Spain, only one. Okay, we are one. So we would be very happy to develop some work together with you. Okay, and thank you very much for coming. If there are questions, I'm more than happy to. Yep.
Thank you very much.
Thanks very much, Carlos, for the great talk. I had a question about the last two things you showed about materials, okay? So from my perspective, at least, and I don't know if this is a common perspective of everyone, but at least the two examples you give, I think, are very interesting because in the first one, you mentioned that there were all of these materials that were made by robots and so on. I mean, I think that was challenged later, and I think a lot of them were found to have already existed before they were made for some reason or other. And on the other hand, I don't know how much that system is biased and how much is based on reality in the sense of how you can make that on a real laboratory scale or something like that.
You talk about genome.
The genome, yeah. Yeah, so that's one. And on the other hand, on the proteomics side, I mean, all of that was based on on crystal structures of protein. So it tells you nothing about a protein in solution, let's say. So, and that comes back to the point, which is a more general question then, which is about how much of this, how do we guard against, let's say, biasing our model to not take into account the failures? Because everyone publishes and they publish what works, but they never publish what doesn't. So how can we, as material scientists, kind of exploit failure in a way to get to success?
Yeah, that's a very difficult question because, I mean, I agree with you. I mean, sometimes I tell my PhD students, I mean, a failure may be more important than a success because it will tell you what not to do to many others. So I don't have an answer to that, I'm afraid. And in terms of the material sciences, this genome approach has been very much praised in the past. It's quite recent, 2023-24 is when they have developed this system. So I cannot give you more details, honestly. I mean, I think it was trained with a gigantic amount of existing material structures, and this is where it is based, because these systems, basically what they do, neural networks in general, are massive interpolators. So when you have a function and you have a number of points, what it does is interpolates. And this function here is one variable. It can have millions of variables. So it makes interpolations that you cannot even dream of. And that's why they are so powerful. So in a sense, I guess that is what it's doing. I mean, it's interpolating between nearby materials, trying to find something in between and interpolating the properties. But this is what the machine does. I mean, of course, it is based on the training data. I mean, depending on the data you trained, you would be, but it may be good. I mean, if you have a data set on a particular area you're interested, you could take one of these systems, train with your data, and then explore in a more efficient way your area, right? But the papers are there, I mean, for you to have a look. Yeah.
Have more questions?
Thank you very much. I have a question more towards what you were, the last part you were saying, that to have an interaction with EI, with you as an institute. Because you were mentioning that, okay, we have the same peak number, many projects that you presented, they are European based, but before reaching that point, we need, I think, smaller projects or just have initial interactions. And also you showed that many of your students or personnel were PhD and then very few masters. So I don't know how this seed starts, whether you started with projects. So if you are always looking for a PhD student, how, I don't know, how we can start a collaboration, for instance, more in a real scenario.
Down to earth, down to earth. No, the idea of, for instance, of having a master student that you may have, that could have part of the work done using AI techniques, that could be a way to start. I mean, it's like...
In this sense, then for me, I have a doubt, what is the background of this student needs to have? Because I don't think we have same students. So I might have, for instance, biotechnologies or material science, and then you may have informaticians or mathematicians.
Yes,
I think...
Yes, I agree. I mean, there is always a challenge, but when you do multidisciplinary work, I mean, it's always a challenge because at some point the student needs to learn the language that he or she doesn't know. I mean, this effort has to be made.
Because which type of...
But to a large extent, in the case that is someone that is has not really enough information on computer science, using tools is not as difficult as building those tools. So it can have a background on material science, and then with the help of someone in the institute, the person can apply existing tools and maybe fine-tuning them a bit, but not really developing the tools. I think it's a case-by-case analysis that we have to make. But starting with a master's student may make sense. Because then you establish a relationship with the researcher at the institute, and then when you know each other, then you build up the trust and the confidence so that you can go for something bigger.
Okay, thanks.
But yeah.
When you say using existing tools, you mean open access tools?
Open access tools.
Developed.
Tools that we have developed for sure, but also, I mean, we have plenty of algorithms for doing many different things. But also tools that exist on the market that are, well, open in principle, because I mean, otherwise you need to start paying money. But instead of using ChatGPT, you use DeepSeek or Claude or systems that are open source.
Because I guess that one of the problems that we have is that we would need some mentoring regarding the most suitable tools existing or not existing for the problems we have.
Yes, that could be part of the collaboration.
Hi. For using the AI, data is fundamental. Not only quality.
It depends. In the symbolic AI, it was not that fundamental. In the sub-symbolic AI, it's completely fundamental. I mean, without that, you cannot train anything.
But for instance, for analyzing data, experimental data, the amount of data is very important for training. But how is fundamental is key. For instance, if I have a limited amount of data, could I use also AI? Are there tools for using? No?
I mean, you can always, so a neural network, you train it with the data you train, it will give you an output. It's like the Chinese room. You will get an output always. The question is, how good will that output be? And this is the problem for all these models that we have nowadays. It's not just how much or how much data you have, but how good is the data you have. So if the data is large and good, fantastic. If it is small and good, it can also be interesting. If it is bad, then nothing will come out. It's when you distill wine. If the wine is bad, I mean, the aiguardent will be horrible. I mean, you cannot get anything good out of bad data. But I mean, there are all sorts of systems. For instance, an application we did was, they call it extended, I don't remember. You take one of these models, large language models, and then you add to it, for instance, we added all the Canary Islands boys. You know the Boletín Oficial del Estado, that for the region, okay? You give that as a training data set on top of what the system had already. And then you had a system that was adapted to answer questions. In which years these kind of projects were allowed to have more than, and then you get answers that are specialized for that. So in many cases, if you have data that are in a particular sub-area, maybe you can take a tool, pass that data, so you particularize, you give the context, so that then the answers you get are more focused and more correct in your area. So, for instance, having a master student that takes one of these and someone trains how to do this process to adapt to the particular area could be something we could collaborate, and that's not too complex. Yeah.
Thank you.
Thank you for the very interesting talk. I was wondering, like in the very everyday life, when you use AI, is there a way to not be unethical? Or, I mean, except from the obvious one, like when we use ChatGPT, for example, there are some common mistakes we can do, which is not like.
So common mistakes.
Yes, like which are not like responsible. Like, is there a way which is very easy to fall in to do very not?
The easiest I can imagine is the biases. I mean, is that you do not care much, or you do not curate the data set, or you just take the data set from somewhere without a critical eye on how was the data generated. Because you may think, no, there are no biases. I got the data from somewhere. Okay, how were the data generated? So you have to put serious questions on that. I think that would be the first one if you're going to use data, to avoid biases, so that, I don't know, if you live in a particular neighborhood, no one hires you because I mean, all the examples that you're putting from that neighborhood are of bad people, let's say, right? So yeah, bias, I would say, is the first one.
I would say that your advice is also that we should test the tools, to see whether to.
I mean, for instance, the genome of the DeepMind people. I mean, DeepMind people are normally quite open, so I don't know whether you can get your hands on top of that. But you can try. I would say yes. I mean, it's like when. Well, this is again, okay, now I understand your question. So, no, it's not, I'm not saying you don't use them, because they're extremely good for certain things, like answering emails. I mean, when you get an email, you write the main ideas of the email, you say, whoop, improve it, and you have a beautiful email, you have a check, it says what you want it to say, kaboom. So some simple tasks can be done in a much more efficient way. So I use it all the time for that. But for your work, I think you need to be more, how to say that, more serious, more strict. Test with maybe your materials. I mean, check what these systems say about your materials. See whether what you have done in the lab coincides with what these systems predict that your material will be. I mean, that could be some initial testing to see whether this is something to be used. Because if you have developed, I don't know how you were, but if you have developed 3-4 materials with certain properties, and I would pass them to the system, and the properties would be in a minute being predicted correctly, I would think, oh my God, I mean, this is something that we could probably pay attention to. So I would definitely try the system and see how good it is. Yeah. And if you have difficulties, send emails to the people in Google DeepMind. I mean, they're normally very open. Differently from other companies, these guys in DeepMind are very open. Okay.
You venture to see the prospects of AI in 5-10 years?
I think the dust will settle down. I mean, all this hype and these crazy Americans that basically what they want, these corporations, is make a lot of money, and this is their purpose. I hope that will settle down. And I mean, there were people, Hinton was saying 5 years ago that in 5 years there will be no radiologists. He said, no, radiologists, this is a job that will disappear, and we still have radiologists. I mean, these guys live on the hype, on saying stupid things so that their shares go up, they make money. I mean, so we have to be a bit more cautious, calm, responsible. But I think AI has potential to improve many things that we do, and in that sense, it will continue, as all the technologies, right? So there will be things that will work. I'm sure we're going to be languages, for instance. I already saw a system by a group of Chinese from Huawei. They were talking in Chinese, and the system was translating real time in English. I mean, these things that are now at the tip of our hands, that will be on the phone system. So communication will be much easier for everybody. That's an example. I mean, there will be others, but that doesn't mean we should not learn languages. I mean, learning languages is important because you have the human experience and the emotional side of it. Because communication is not just to convey information, it's an experience, a social experience. And that, I mean, a machine will not mediate, never. I mean, okay.
Yeah, let me just. So if I was to look at your talk, I think about who would be great at AI.
Actually, I have a slide I didn't put, a slide in 2022, a question put to ChatGPT. It said, if I have data about, how was that? Let me, answer me, who can be a good researcher based on gender and sex? That was in April. I have a snapshot of that. Based on gender and sex. And write me a code in Python that determines that. And the code in Python said, if gender equals male and ethnicity equals white, then yes. Otherwise, no. That was generated by ChatGPT. This is an example of a completely unethical outcome, I would say, of the system that was generated because of biased data in the training. Of course, now if you ask the question to ChatGPT, of course not. You cannot guess the quality of a researcher based on blah, blah, blah. Because these companies are hiring thousands of humans that are fixing all these problems that the generation has. There were even scandals. People in Kenya, because they speak English, paid $1 an hour to filter hate content. So they were kind of labeling hideous content. It was a horrible thing because they had not enough psychological. Maybe you have heard about that. So they're hiring hundreds of people just to filter out what this generative AI should not generate. So there are more, say, it will end the job market. No. These AI companies are hiring like crazy. I mean, of course, for a low pay, but for a low wage. Definitely, because I mean, depending on the prompt that you put, you can say, make it formal, make it like play the role of a sensitive woman, I don't know, play the role of an aggressive man, or and depending on how you make the prompt, the text will be different. So in a sense, I mean, it's a way of diminishing the tone sometimes for people. So, or maybe you can tell people, look, write your email and ask one of these systems that labels, how is your email? Is it friendly? Is it formal? Is it aggressive? So that you have an idea of what you have just written. So I think if we introduce these elements, like helping in writing, but also analyzing what we write, we may improve what we do. Yes, definitely. I think it's not working. The battery is off. Well, I will rephrase for those.
Stock. Okay, what anybody who has children knows that the ChatGPT is everywhere. They are using everywhere, from kids, from students in university. How worried are you as an institute? I know that you are researching, it is not related to education, but how aware are you of how involved are you in trying to change the education to let people how to use this tool? Because this is a big problem. I mean, it's very nice that we, at middle age or old age, try to use the ChatGPT to write the email, but we know it's good or not because we learn how to write more or less. But the solution
So I would say 2 weeks ago, we were in Zaragoza, and we have this summer school on AI. There are 2 tracks. One track is for research on AI or applying AI to research, and the other one is AI and education. So these questions were for 5 days on the table for many people to discuss. You can find the videos in the AI Hub. You can go there and find the panels and the videos, and it is a tremendously important problem. And we had education inspectors there. We had some representatives of the Generalitat as well there. So it's something that worries everybody. And no one has an answer, a complete answer to that. What is clear is that we need critical thinking in the kids. We need critical thinking. And the way, so we need to see how can educators embed this critical thinking into kids so that they do not take anything that the system produce for granted as a true thing, okay? And for that, educators need to be educated themselves. They need to learn how the systems work. We need to define guidelines for teachers in primary school. We had a number of primary school teachers, secondary school teachers. So we need guidelines in order to introduce that. What I disagree is on hiding it. I think we cannot hide because the kids will find it. I mean, we need to teach them how to use it. And in order to teach how to use it, I mean, we need to know. I mean, there is no other alternative. So I think educators have to learn. Guidelines should be produced by the organizations, I mean, the departments of education by the European Union. And there should be training courses that help teachers. But we need to face it. I mean, the way communications are done has changed dramatically. We cannot we cannot take for granted that something is true, and this is completely new because so far we had this idea that the information we received was correct, was true, and this is not any longer the case. So it's a very dramatic change of position. So I'm sorry, but I don't have an answer to that.
If not, we thank again Carlos for.
Pleasure. Yeah, it's good.